All right. Well, I don't have a ton of slides today because I just kind of want to go to a notebook because that's kind of what you're going to be doing on the midterm. I'm going to give you, at least that's the plan for this semester's midterm. I'll give you access to this little online Jupyter notebook where you have essentially this blank slate with all the nice things imported for you, and then I'll ask you to do some stuff there so you can see your answer before you submit it on the test. Like you can see that it's right in theory. So that's the goal. You'll have access to all these different reference pages. I guess I've gravitated towards this one, but of course you could use the other one, either one you'd like. Does not matter to me. You get access to both. But I think what I'd like to do to start today is just kind of go through some of those table operations. Like we're going to look at the documentation. You'll have that available to you. Let's just remember what everything is so that you can use it. And if you have a question, just ask. But let's make just a little simple table. This doesn't have to be the world's longest review today. But yeah, let's figure out how to do things. So first of all, table with a capital T, right? Call it like a function. It makes a brand new table that has nothing in it. No rows, no columns, no nothing. Completely empty. And then you can give it stuff, right? You can take a blank table and give it stuff. Like table, that's a blank one. Nothing there at all. And then I can say dot with some stuff, with columns. You can do with column if you only have one, you want to attach, but plural if you have multiple. And eventually you got to close that off, right? And then it's just a bunch of pairs of things. You're going to give the name of this column that you'd like to add, the next one you'd like to add, and then you're going to give an array, right? An array of what's going in there. So let's do an array of animals. So the names of some animals. So make array, remember, makes an array of things. And so, I don't know, let's do my cat Lonzo. We'll do Tony the Tiger from Frosted Flakes and Victor E. Bulldog from Fresno State, their mascot. The living mascot. So like that's one column, and it's got a name. So I can stop right there if I'd like to. I don't have to put another column here. And that will make a table with just the name column, right? Just the name column. But if I want to keep going and give more, I can give, these are arguments to the with columns. It's called a method, but it's just an operation, right, on tables. Think of it like a function call. Maybe we can attach a species to each of these elements. So I'm going to give an array also of size 3. It's got to be all the same size, right? Unless you want to give just one value, there's a trick where you can like give a single value, I don't know, animals. And it will just attach that to everything. That's a little trick. I don't know if that's ever going to be useful to you, but like that's a thing. But usually you're going to want to make an array or give an array that you've pre-made to go there, right? So like Lonzo is a cat, Tony is a tiger, and Victor E is a bulldog, all right? And then I have this so far. Like I've got 2 columns. These are their labels. These are their values. And I've got a bunch of rows, right? The rows are the horizontal things, the individuals in the population. Remember all the terms, right? So we got those guys. And then let's do like an age. So we have some numerical column stuff. It's like, what is the age of all of these things? Make array. Lonzo is 5. He's a pandemic cat. And then I had to look this up, but apparently Tony the Tiger existed with Frosted Flakes from the beginning of Frosted Flakes' inception in 1952. So Tony the Tiger is very old. So however old he is, Python can do the work for us. And then Victor E. Bulldog, they replace him every so often. I don't know how often, but let's just say Victor E. is like 8 years old or something. But there, I've got a numeric column, I've got some categorical columns, and I have made a table, right? And I can call it something, give it a name. I can say T is that table. And you know that at the end of every cell, you can put something and it will just try to print that thing out for you. So I've made the table T, and I've printed it back out to me. And I can do stuff with T now by saying T dot something, T dot something, all right? So yeah, what do we got in our documentation? You can additionally read a file and get a table. So yeah, you can say with column or with columns, and it's just a bunch of names and values, name value pairs, till the end of time. So yeah, let's just kind of go through some of these just to make sure what's going on there. We know what's going on. I guess I can kind of look at them here. You can get the, like how many rows, how many columns there are, and then also the labels of the columns, and those are not functions, those are just like variables attached to the table. No parentheses there, right? That's how you read that. So, all right, table T, how many rows are there? There are 3, right? 3 rows, also 3 columns. So the rows are the horizontal things, and the columns are the vertical things. So num rows, num columns. Cool. And then you can also ask for the labels involved of the columns, right? It'll be the labels of the columns, and you'll get that back essentially as a sequence, just with parentheses. Slightly different kind of sequence, but treat it like an array if you want to. So yeah, that's how you get those things. Let's see, what else do I want to do? Just a bunch of these little table operations. You can get out a column. We'll do that a bunch later, so I'll save that. But yeah, let's like select, right? You know what select does? It lets you reorder columns. It brings most of these operations, right? They give you back a new table. That's also important. Like you say t.table.select some columns, it will make a brand new table for you with those columns picked out, right? So that's very important. And it's not going to change the old table. So it'll be like t.select. I don't know. Let's do a table. Let's take this table and only get like the, I don't know, the name and the age. So you can say select name and age columns. And it will give you back a brand new table with just those things. And T itself has not changed, right? Very important. Some of them do change it. I'll teach you a different one than the documentation for relabeling. Yeah, that's how select works. You did not have to give the names of columns if they're long. You could have given indices. That might be faster on an exam or something. Like this is, it always starts at 0, right? So the name is column number 0, species is column number 1, age is column number 2. So instead of saying age, I could have just said 2. Instead of name, I could have said 0. Like you can interchange them as well. Like, it's still the same thing. Still the same thing. Still T has not changed. Okay, so that's a thing. Let's see what else. So that's select. You can pick things out, and that also lets you reorder stuff. Like you could have said 2, name. Give you back those in that order. Like maybe that's more interesting to you. I don't know. That's a thing. So that's select. We've got most of these work on column names or indices, right? Drop is kind of the opposite of select. It gets rid of something for you. So t.drop the age, just to give me the name and the species. Cool. I get those things for myself. Yeah, that's most of it, right? You can relabel stuff. Let's do that. We can say, and this is the one that I don't like is in the documentation. I think it's here too, right? Relabel. Oh no, they do it right on this one. Relabeled past tense. So do be careful if you're looking at this one. What this one does, relabel modifies the table. So that one actually changes the table, and I'd rather you stuck an ed at the end of that. Relabeled, because what that one does is it gives you back a new table, like all the other operations we know and love. So if I want to say something else, t.relabeled, let's relabel like the name column to, I don't know, Spanish. Nombre. That does not touch the original table still, but it's relabeled the name column to something different. Okay, so that's what we get there. Yeah, shout out if you have any questions about this stuff. Yes.
Just to clarify,
relabel
modifies the original table.
That will change T.
Relabeled is just a new table.
Gives you back a new table, just like all the other operations. Why did they care to put that one in this documentation page? I do not know. You have both options, but I think we would all prefer the ones that don't touch other things. It's like only change stuff when you want to change it by assigning to a variable. I think that's a good strategy and worth it. All right, so do be careful about that one if you're using this documentation page. This one has it right where they show you relabeled instead of relabel. But I don't know. I've gotten used to this one. So that's that. What are some other ones? Dun, dun, dun. Show. Yeah, it doesn't really work for this one. Show, it just shows you, right? You give it a number and it shows you that many columns, or sorry, that many rows of data. So by default, when you print a table to Jupyterland, you just say its name. It gives you 10 rows. but you can ask for just 5. You could ask for every single row at all. If you forget to give, you just do parenthesis, parenthesis, it will give you the entire table, print it all out to you if you want to see that. No n is provided, displays all rows. That's how you can read that. Very useful. Yeah, let's show. Sort we'll get into, right, which that's going to take a column you want to sort by, or an index of that column, and by default it is ascending, so it's from smallest to biggest thing. So you're going to sort by something that's like numerical, or if you sort by words, it'll go dictionary order. You can have it reverse ordering by saying descending equals true. So that's a thing, and so the documentation is trying to show that to you, and I will have an example of that eventually. Yeah, that's more or less that. What else do we got here where we get to like displaying things? Dot where I'll show you examples of. You give it indices. You give it a bunch of indices of things you want like to take from. So like take index 0, so by the rows, and you could get the very last thing by taking rows minus 1, because that's always the index of the last thing. And then you could also just start giving either an array of indices, or you start typing out the indices. Like I want the 0 thing, the thing in index 1, the thing in index 2 as well. So take gives you certain pieces, certain rows out of your table if you want something specific. Like maybe you sort, and then you say, I would like the 5th highest one or something. So you'd sort reverse order, you'd take index 4 then, something like that. Okay, question?
Dot pick only does rows, or does it also do columns?
It does rows, so you'd have dot column for giving yourself an entire column. Yeah. So it's going to do that with only the specified rows included. Rows are specified by their integer index, so 0 for the first, 1 for the second. So that's very helpful that you have this documentation page open. You are welcome while you're taking the test. We'll do dot where a lot. I'll give you examples of that in my longer example of the day. But just briefly, when you say dot where, you can give, I forget which chapter this was in. Maybe I'm going to pull the slides from there. But you can say, you have a table. You say, I want just a piece of the table. You'd like to extract some rows. Again, this is row-based. I'd like to extract some rows where this is true about those rows, where this column's values are above 10, something like that. So you have an entire option, a bunch of options of how to do stuff, the are above stuff, table.where predicates, cool. So you can look at this to know what's there. You've got equal to, above or equal to, so you have to spell it out, but they're all mentioned in the documentation somewhere. So this will help you pick out pieces of rows. Most of these are most of these are about numbers, right? Most of these are about numbers, between or equal to, but some of them are string based. So like containing is good for strings, right? You got a bunch of words. Give me pick out the rows where this column's values in it have the string at somewhere inside of it. Remember that strings can be double quoted or single quoted. Does not matter as long as you're consistent. So yeah, that's most of the table stuff. Do just yell at me if you have questions. I'm going to have a longer example for the day once we just get through most of these. But next is visualizations, right? You have scatter plots, which have little dots, right? You give it at least an X column. It'll graph multiple things if you don't give it a Y column, right? We haven't talked about fit line yet, so don't worry about that. But like you give it the x-axis, the y-axis, and it draws little dots, like points from your data set. And plots, remember, that's more for chronological stuff. That's a line plot. It kind of works exactly the same as scatter, but it's just going to connect the dots because it's, in theory, you've got something in an order. Yeah. So that's how that works. Bar H is a horizontal bar chart. There is a bar, just a dot bar, but we don't use it because it looks really disgusting if you try it. Like it can't like put the labels small enough and in the right way. But you give just the name of a column that serves as your categories. It's got to be based on a categorical variable, right? Something that you can split up into multiple things. And then you also have some numerical values attached to that. So I'm going to give you an example of that soon, but like that's kind of how that works. And then our good old friend, the histogram, which I'll show you examples of as well. But a histogram is just like you're trying to show the spread of a numerical variable, right? How far away from different values does it get? You're going to start binning things and counting things in the bins and getting weird percentages. So definitely go back to those slides if you've forgotten how to do all that. But yeah, you've got a bunch of cool things. I'll show you apply. You've got group and join and pivot. Let's do an example of scatter just quickly. I'm going to make a table and we'll graph some stuff real quick just to show you what this looks like. X column, Y column. Whee. What do we got? We've got let me make a table really quickly by using my np.arange stuff. Do you remember that? How to make a quick range of numbers? Because that's going to be important. Where's that? Probably here somewhere. np.arange. You got three options to this function. You can say a stopping value, and by default it goes from 0 up to that -1, right? It's always up to the stopping value -1, incrementing by 1 by default. Or you can say, no, I want you to start at a different value, and here's another stopping value. So it'll start at this value, go until this one -1 again, increasing by 1s. Or if you want to go decreasing or by 2s, by 5s or something, you can give the full thing. You have 3 arguments, the starting value, the stopping value, and how much you want to step by. So it's always going to go up to, but not including the stop value. So here are some examples of this. np.arange 0 to 11 gives you the numbers from 0 to 10. So it's inclusive on the start, exclusive on the stop. So it goes up to 10. By default, it's increasing by 1 each time. If you give nothing, just it's going to give you an array that looks exactly like this. By default, it starts at 0, goes up to, but not including 5. By 1s, though. And then you can count by weird numbers, including by floats. It'll just always go up to, but not including 102. So that's the last value that you could get, apparently, until it's a little bit bigger than 102 or exactly equal to it. So yeah. Questions about np.arange, because that's going to be part of the next example. It builds a nice array for you if you have a pattern. And of course, you can go to pieces of arrays with .item. You can shuffle arrays. You can take a piece out of an array with np.random.choice. So definitely look at all these. I can't go through everything today, but I'll give you a few examples. I have just one long-running example after this. So yeah, here is, let's just do x's and y's. So an x column can be the numbers from, 1 to 100, but by 5s. So let's make an array. So I'll do, if I want the numbers from 1 to 100 by 5s, np.arange, starting at 1, going not just up to 100, but let's do 101, and then incrementing by 5s. So this 101 here is very important. If I said 100, oh shoot, no, sorry, I want... if I wanted to end at 100, maybe I have to start at 0. Cool. So that's beautiful. I can do that one. By 5s, though. So if I just put 100 here, it would just go up to 95, right? That's not what we wanted. So remember that. So 101. You could also say 102 here. That's fine. Just up to, but not including that. So you can put any number that's smaller than 105 there if you wanted to go up to 100, right? That's how it could work. So I'll just say 101 because it makes more sense to me that way. So that could be my x values. And then the y values associated with them will be, I'll just make a little line, something that's also increasing. Let's do, I don't know, how many was this? 20 values or something? Maybe 21 if I'm off. But let's make a value, let's make a descending thing now, because I could make also, and this is an array that you can ask how long is it, right? What's the length of it? It's 21. Cool. All right, now I know. Let me actually keep that separate so you can see that. That's a way to get the size of something, right? You got min and max and all those nice functions. Again, they're somewhere in the documentation, I think. Min, max, len, sum, things that you could do on arrays. Get the maximum, get the minimum, get the sum, get the absolute value of a single value. I don't know why they put that there, but it's you can take an entire thing and do also abs on it. np.round rounds an entire array of things, so that's kind of cool. But len gets the length of the thing, so I can ask for the length of that thing, right? Like this. You have an array, you can ask for its length. I could have put that array into a variable, that's fine. But let's make also a 21 size thing so I could put that in my little graph here. let's go from like 200. NP to A range. 200 to 0 by negative 10s. Is that enough? What's the length of that? That might be 20. I don't know. If that's what I want. Yeah, that's just 20. So I need to go one more then. Let's have it go down to negative 10 then. Or have it go down to 0, because right here I put 0, and that's my stopping value. Even if it's descending, it's never going to get there. So if I wanted it to go to 0, I could have said negative 1 or something, right? Just anything that's bigger than negative 10, because otherwise it would have gone down to negative 10. Cool. Oh, sorry. And then I'll have a length 21 thing that I could also put here. Those can be my y's. And there's a nice table with 0 and 200 together, 5 and 190 together. So I kind of want to graph the x and y pairs. So that screams scatter plot, right? I got a bunch of things, and that's how it looks. All right. So those are my points from my data that I collected as a scientist or something. And you can say, do I want to call it? I'll call it T2 because we already had a table T. And I can say, make a scatter plot of this by saying T2.scatter. I legitimately call the x column x and the y column y. So T2.scatter x and y. And it's beautiful. Yay. So that is the graph, and by default it has those ranges for its x and y axes. There are ways to change those ranges, like even though it goes only up to 100, you could say make the graph show up to 200 if you would like, but that is not very important for the test. So yeah, you could have said just the x column. That still would have worked. It just would have graphed every other numerical thing. Whee! There it is. So it found the y as well. It was still there. Just what do you want to use on your x-axis? It can figure out the rest. So either one would make the same graph for you. You do have options. Okay? And so yeah, that's kind of what I wanted to say about most of just the table operations in a nutshell. I'll give you more examples of more advanced ones, like I'll show you apply, I'll show you group. Yeah, we're just going to go with a fancy example that involves like loops and functions and like conditionals, if-else statements, stuff like that. That's what I have for the rest. It's just like an involved example. Are we ready for that? Or are there any like things you want to see from this page that like you're a little fuzzy on that I could go into more depth on? All right. So yeah, let us use the rest of this time to do a silly example. I have made a data set for us. If you'd like to get it, I'll show you the name of the file. It's there. I've made a data set of for the original version of Wordle, all the words that are possible to be chosen from. I think I also have a data set of all the things that you're allowed to guess, because there's a bunch of different words that you could have guessed, but might not necessarily be on Wordle because they're like harder words and weird. But have we all played Wordle before? Like it took the world by storm, right? It's like it's a game where you have a 5-letter word to guess, and you have 5 guesses, I think, right? Total to get it right. And every time you make a guess, like the first guess for this person was arise. It's like an earlier game from like years ago. It will highlight in yellow if you got like a letter that was part of the word. The secret word, apparently it was rebus, or however you pronounce that. It'll give you yellow if you got like those letters were part of the word, but they're in the wrong place. It'll say green when it is part of the word and it's in the right place. And this is just somebody guessing letters until they figure out like, okay, yes, I know that it starts with an R and ends with an S. There's a U and an E in it, but not there. It's in the wrong spot. And so eventually they figured out what it was. All right. So what I will do is, for my example, let's figure out the best starting guess for Wordle. All right. That's what we'll do with our words data set. So here it's called this. It's in my data folder. It's just called Wordle. It's wordle.csv. There's also the Wordle with every 5-letter word that you're able to choose from. And this is from the original version of it. I think the New York Times has changed it probably slightly. But this is back when you could get all that data very easily. But that's going to be my extended example for the day, and I hope that it helps. So shout out if you have questions about it, but let's get this into a table now. We know how to read from a table. It's here in the documentation if we've forgotten. It's table.read table. And this is without parentheses, right? Table not with parentheses, but table without parentheses. .read table. Interesting. And then we give a name as a string of a file. So it's my data folder / wordle.csv, and I'm going to call this table words. And then here they are. This might be in like the original order of the Wordle things because it's not in alphabetical order. You could sort it if you wanted to, but I'll just keep it in this order. But here's my words table. It's just one column. It's got all the words that could ever be on Wordle. They're all 5 letters. They're all lowercase. Okay. And what I want to do is essentially figure out like what is the most common, what's the best word to use at the start, which is going to involve like, all right, out of all of these words, what letters are the most common in the 5-letter words that are part of the Wordle game, right? That's what we need to kind of count right now. So we need to count letters. So we need to go through each of these words and figure out like how many C's are in every single letter. How many A's and B's and C's and D's as well. And a way to go through a word is you can actually secretly treat a string like an array. This is not something that I care about teaching too much, but we need this fact. You know that you can go through a loop, right? You can be like for I in np.a range, I don't know, 1 to 10, so 1 to 11, like print I. This will print out all the numbers from 1 to 10, and it goes through this array that was 1 through 10, all the values from 1 to 10. A string, you can also do the same thing. You'd be like, all right, it'll give you every character. For every character C in the string hello, print C. So this is a way to pick out each individual character and do something with it, because that's what we need, right? We want to go through every 5-letter character. It's essentially, what is a string but a sequence of characters? So like that's how the for loops treat strings in Python. So that's great for us. That's exactly what we need. We'll get each character one at a time. We can call it C, call it whatever we want. And then each time we have it, instead of printing it, we'll just like add it to like our list of all the characters we've ever seen. We can count things at the end. Does that make sense, that idea? It's kind of cool. So I essentially want to go through all the words here and count the characters in it. So in that case, maybe my goal then can be, I would like to make an array of every single character in every single Wordle word. Right? That would be great. If I had that, then I could count all the A's in that array, because it would have every single character of every single Wordle word in it, and then I'd know exactly how many A's were in every word. How many B's. So that's my goal right now. I'd like to make a big long array of all the characters of every Wordle word. Okay? And so the first step would be, let's maybe take a single word and turn that into a sequence of characters, because the for loop kind of splits it up, but does not give you that sequence. So I think we could make a function that does that, kind of using this as the setup though. So here's kind of the idea. Let's say I can make an array, right? Call it array maybe. It's empty. And we know that we can take, like, for every character C in hello, what we can do to that, right, is instead of printing it, what I can do instead is maybe take that character C and add it to that array. Because then I would put it in there, right? So that would work for every C and S in my array, or in my string hello. I could attach something to the end of that array with np.append. Right? We've been doing that a lot. So that is here somewhere, if you want to remember it. There it is. np.append takes an array, and it takes another thing that you like to add to it. Potentially also another array. It'll just like combine them together. The other thing was also an array. So that's perfect for our purposes right now. I want to append to the existing array a brand new character. So it starts out empty. It's just called array. I'll say np.append to the end of array the character C, and that will produce a brand new array for me. It won't change the old one called array. Just like set it back equal to that. And like that's... Do you see how that's this process then? I'm going to go through every character C in hello, add it to the end of an empty, starting initially empty array. It will end up with each individual character as a string of hello in an array. Does that make sense? Yes.
So it's an array of characters after, essentially.
Array of characters. What did you say after that?
So basically, you're just getting, or it's counting each character in hello, and then just putting it in an array, basically.
It's not counting. It's going through.
That's what I
It's just looking at every character. It has no clue how many there are. We can ask that later. But all we have now is just like we're picking out every little character. The for loop picks out every character, and then one by one I'm adding to it an initially empty array. So I'll end up with an array of every character in that word. Okay? So let's take this process and turn it into a function. To make a function, we say def. We say the name of that function. My goal right now is to take an individual word out of the Wordle list and turn it into an array of characters, because then I could just do that for every word and append to like a big long list of all the characters. So I want to take a string, call it str, to array. Like that's my goal. Give me a string called s. I will give you back an array of all the characters of that string. So it's essentially you paste all this. And it's just like for every character C, not in hello, but whatever S was, right? Whatever that S that I was given was, go through every character in it, please, make an array out of it, and give back that array with a return. That's the last missing piece for functions. So if we want to give a value back, we say return that value, okay? Does everybody see how I took this and generalized it? Because that's key. That's how we make functions. Usually you want to start with a little example of like kind of what you want, and then you can generalize it to work for anything that you could ever possibly want to be given. So yeah, somebody gave me an S, it's a string. I go through it, I make an array of things, I give back that array of characters. And so now I can call it str to array on anything, including hello, but it could have been another word, like it could have been ABC. And it's always going to give me back an array, return back to me an array of all the characters in that word. Okay? That's useful on my journey, right? To build an array of every single character. Every single character in all the Wordle words. So I'm going to have to like go through, iterate is the fancy word for that. I'm going to have to iterate through all of those words eventually. And then I want to put them in just a giant place, an array of every single character in every single word. So np.append doesn't just, sometimes you can give it an individual thing, but you could also give it another array. np.append also works on two arrays at once. So again, that's not something that the documentation is saying that I'll really test you on, but it's necessary for this example. So if I had two arrays, I could say np.append each of them to each other. I could be like str to array, right? That's my function that gives back an array of characters in a string, in a str. Say hello there. I could append that to another call to str to array, like world. And so this will make the array of all the characters in the word hello. This will make an array of all the words and all the characters in the word world. And then np.append will give, it will take those two arrays and just like shove all their elements together. Isn't that nice? So that's what I want essentially. One by one, give me an array, split it up using my str to array function. Split up every word in my list, and I'd like to just keep on adding every single character I've ever seen into some final place, okay? And so that will give me, eventually, if I do this for every word, it will give me an array of all the letters in every single word or word, and then I can start counting, okay? That's what I want here. So I think that is my goal, and now essentially I just want to do another kind of iteration. Right? I want to make an array of all the letters in every word, starting off empty. So make array with nothing, just like a table with nothing makes you a blank table. Make array with nothing makes a blank array, nothing in it yet. And then I want to iterate through. I want to go through every word in this words column, and so I can get that out. Right? You remember that column gives you back all the elements of a column. Like words is my table, right? I can say words.column. Capital words is what it is, right? That will give me everybody. That's everything, all those 5-letter words, and I can go through that with a for loop as well. For loops go through things that can be, that have elements, have pieces. So I can say for every word, let's call it, in words.column words. And if you didn't want to type that, remember that you could have used the index as well. You could have said words.column. What number column is it?
0.
0. Good. Yeah, it's just the first one, first and only one. So I could have said words.column0 there. And now I have, for each piece of that, I have a word, right? I'm getting each string out, each word of this words of this column. The first one's cigar, then it's rebut, and it keeps going, right? One at a time, they're all going to get a chance being called this variable word here. Okay? That's what's going to happen. That's how that works. And for some reason, why can't I type? There it goes. So, all right. What do I want to do? Yeah, so each time I have a word, I kind of want to call my function on it, right? I've got my stir2array function, stir2array. On that word, whatever it was, the first time it was cigar, right? And so that will give me every character of that particular word that I'm working on right now as an array. I just want to shove it into this array as well. Starts off empty, so it's going to be with an append, just like we've been doing. So take np.append to this existing array that I'm going to keep track of every letter and every single word or word right there. Here's the new one, right? This is an array. That's fine. And we'll just like take each piece and put it in there. All right, append works like that. Doesn't need an individual thing. It'll be happy. So take that. This produces a brand new array. And we'd like that to update letters and everywhere. Because like if I didn't do that, right, this would still be empty forever. So I'd like to have that become letters in every word. The result of appending to whatever it used to be, this brand new, all these characters in this brand new word. All right. So every word in this column gets a chance at being called this variable word. I could have called it S as long as I was consistent. I just say S there. Whatever you want to call it, I'll call it word. We're going to get all the characters as an array of that string and shove it into this array here. All right. Does that make sense to us? Questions about that process? So that's a good example of like loops and functions and arrays. So I think that's hopefully going to be helpful for you. And then eventually we're going to have back a brand new array, right? Started off empty. We put every character of every Wordle word in it. And that's what it looks like. Wait, it starts with CIG. And apparently the last letter in the table ended in AVE. We can check what was the last Wordle word in this table because we know how many rows are there, or it also knows itself, right? Oh, why is my clicking not working? There it goes. You can say words dot take, right? Take, you can give it an index. What's the index of the first thing? 0, right? Which means the index of the last thing is however big it is, how many rows there are, -1. So words dot take words dot num rows -1 will give you whatever the last one was, and apparently it was shave. That's why it ends in AVE. Cool. Now we know. Yes, I've got this array now of all the letters in every Wordle word, and how many letters total, but it'll be a multiple of 5, right? But we can say len, we can see whatever was in there, letters in every word. Len of that. 11,500, kind of. So that's a lot of words. A lot of characters of every word, okay? And now my goal is to, like, count how many A's were in this big long array, right? Because then I know how many A's were in every Wordle word. How popular was that letter? Do the same for B, do the same for C. Does that process make sense? That's what we need here. And I can do kind of like a count here. I can say, you can have your array, right? You can say its name, letters in every word. And you can give like a comparison. You can be, hey, which ones of those are double equals for equal, right? Which ones of those are equal to, I don't know, H for hello or something. A lot of times it's false, sometimes it's true, but you got a bunch of falses and trues, which you can then shove into count non-zero, right? That's always the process. So you can do your conditions. Is there a table of all the different ones? Not here, at least. And then you can do np.count non-zero after you've done some sort of comparison or otherwise ended up with an array of trues and falses or even numbers that are sometimes 1, sometimes 0, and you don't care about those. Like count non-zero with trues and falses is fine because false is 0 and true is 1. So I can say np.count non-zero. After doing this kind of comparison, all the letter, like take every piece of letters in every word, compare against H. Sometimes it's true, sometimes it's false. How many times is it true? 389 times. Does that make sense? How this process is going to count how many H's are in every Wordle word. You see that? And that's useful for us. That's useful knowledge. We can do the same for like a value for a vowel. More popular probably, like if we're doing hello, it's E, right? There's a lot more E's than H's in every single Wordle word. But does it make sense why this is going to count? Because I have an array now of every character in every Wordle word ever. You see how this is going to count all of the E's, how many E's were in every single Wordle word. Because we did that process of splitting it up, putting every character into one array. So that's kind of what I need. And I just want to count every single letter now. I want to count all the A's, the B's, the C's, the D's. There's a way to automate this. And I think a good place to start would just be to make a table, right? Let's make a table of all of the letters of the alphabet, and then next to it, put all the counts for all the Wordle words of those letters. So let's start with a table of just all the letters in the alphabet. Table dot empty table with a column, just called like letter. And I would like an array of all of the characters in the alphabet. What if I did this? I can be like I could start with all the letters in the alphabet as a string, A, B, C, D, F, G. Hopefully that was all of them. There it is. And then I have a nice function that creates an array, right? Because what I need for a table is an array of things. I have my stir2array function. So this will split up this string of all the letters of the alphabet into an array of all the characters of all the letters in the alphabet. And that might work, right? I think it's happy. And I think there's 26. Cool, I think I did it right. Hopefully it was in order. I'll call that letters. That's kind of nice. So we're using our function in a few different places. Cool. If you want to see the whole thing, you can say dot show with nothing. Give it nothing, it'll show you the whole darn table. So there is my table right now called with letters, just the letters A through Z, in whatever order I gave to this string. So that's kind of nice. So I use my function to make an array of all split it up. Do it for me, because like that was easier to just type. Instead of make array, quote A, quote B, quote C, right? That's so much easier to do it this way, using the function that we've made. So now I would like to attach to the A's. How many A's were in all the Wordle words? Attach to the B. How many B's were on? So I want to add a new column, right? I want to add a new column using maybe the value that I see there. So think about it. If I want to do it this way, count non-zero letters in all the words, H-E, L-L-O, all those things. Like I want to run this process, right? For every character, for the A's, for the B's, for the C's. Then I think I could make a function, right? I could generalize this because like this process is the same regardless of the character. Just like let this be a variable, right? Let this be something somebody gave to me. So let's do that. So let's make a function called a count character, and let's have the character be called C, right? It's like this is a process I want to do a bunch of times for a bunch of different characters. Let it be whatever was given to me. Does that idea make sense? Like return back that value. It's always returned with a function. But like I can give this a name. I can give this process a name so I could call it. Then I can say count character H again. Count character E again. And then that'll go through the letters in every word, see how many times it was equal to that one, because E is being passed up into C here, H is being passed up into C here. But the fact that this is a function now means I can apply it to my table of letters. Yeah, do you see where I'm going with that? That's useful. So, okay, now that I have this function, I can dot apply it, right? I've got the table called letters. I can apply it to the letters column. Where's that? You say the name, you got table name, dot apply, name of your function, and then what does that function need to be called with? It's going to take some values of your columns. For us, it's going to take our one and only column called letters. So that's what's about to happen. We're going to apply a function to a column of our table, and it will give us back an array of the results of calling that function. All right, that's what's happening. So cool. It only took one argument, but if you needed multiple arguments, if your function took multiple things, you just start giving all the column names one after the other. So that is my goal. Does that process, does that idea make sense? So I needed the function so I could apply it to this table, because then I have an A, a B, a C. It'll do it for me. That's quite nice. So let's see here. I would like to say letters. That's my letters table, right? Letters.apply my function called count character. There it is. I don't call it, I just say its name because it's going to call it for me, to the letter column, please. So you could say 0, you can give an index, or you can say letter, whatever you want. And what will happen is it will apply this function to every element of this column and give you back an array of all the answers. So this is how many A's, or in every word or word, this is how many B's, how many C's, D's. It looks like E was the most popular. So vowel makes sense. Only 40 Z's, even fewer X's, surprisingly. Crazy. This is probably 27 was Q, I assume. Interesting. So yeah, those are all my values, and I can now attach this as a column to this table, right? I can say letters dot with column. I'd like to put there, let's call it count, because I use singular letter here. And the count column can be all these counts here. Just like that. And now associated with each letter, A, 979, B, 281, C, 477. Isn't that great? I can call that something, give it a new name, like letters and counts equals that. Show it. If I want to see the whole thing, I can say dot show, right? There it is. So yeah, it was only 29 Q's. A J, apparently J was even less popular. Surprising. Not a lot of 5-letter words with the J in it. But Z's 40, X's 37. Wonderful. So I got this nice table. Does it make sense how we got it? Because it was a long process, right? Took a couple functions, a few loops, or several thousands of loops, technically, if you count like what's happening inside of each function. So a lot of things got us here. It'll be great to review, I think, and study. But are there any questions before I move on? Like, do we all see the vision, how we got here? A lot of things, lots of loops, lots of functions. We applied a function to a table. So yeah, it's the best example I could come up with to practice all these things. So, all right. If we are good, I guess our goal now is like, all right, go back to the eyes on the prize. I would like to know, what is the best Wordle word to guess first, right? To get me the most, have the best options, or give me the best possibility of getting as many letters as possible. So I want the most popular letters in my first Wordle word to guess. That is my goal. Let us do that. So we've got this table called letters and counts. I would say probably sorting this would be a good idea right now, right? Let's take that and sort it. So let's sort it by count, of course. Dot sort by the column called count. By default, it goes ascending, but we can say descending. If we want to see the most popular ones first, descending equals true. There it is. And again, this gives you back a table, a brand new table, doesn't change the original one. I think say dot show, just to see everything in order. And so, can we think of a word with E, A, R, O, and T in them? Apparently, that would be the best word to guess first, right? So that's kind of cool. We can turn this into a graph as well, but like, we're getting somewhere. We're getting somewhere. We're being data scientists right now. So I think a good thing to look at right here, if we want to see like relative amounts of all the characters in the Wordle words, I think maybe a bar chart would be great here. You can go by all the characters and do like dot bar H, right? Because the characters in the alphabet, that's a categorical variable, right? All the letters. So let's do that and say dot bar H, and we can give letter. And then it will take the other value, that's the count. So I can say it's letters and counts, right? Letters and counts, dot bar H, using the letter column as the categories. So like, look at that, it's beautiful. Though by default, right, it's going to give you the order of those categories in the original table, If you want to do a bar chart in this kind of sorted order, you can sort first and then say dot bar h. Because like this produces a new table, doesn't it? So like before, without doing dot show, like take this table, this one that's sorted now, and then tack a bar h letter on it. That would work. Maybe that's prettier. All right. So again, you can see like the relative power of E and A. So good old vowels, O and I. Where's U?
Above Y.
Oh, there we go. So not super popular, but still up there. And then you can see how unpopular J, Q, X, and Z are apparently. J is kind of surprising to me. I guess we don't have a lot of words with J's in them, or at least ones that are 5 letters and popular enough to be in Word. So cool. If only we could guess the word irrit. That would be great, right? Question? To where?
Just right there.
There. Yeah, you good? All right. Yeah, any questions about what we've done so far? Does this make sense? Like, this is kind of something you'd probably want to see, right? And now you try to find a word with E-A-R-O-T in it, and I don't think there is one. So the next best thing would then be, let's start picking out all the words in the Wordle list that have an E in them, right? And then from that, we can whittle it down and like have the ones that also have A's in them. Let's see. I think that's a good next step, right? Let's start whittling them down by doing a dot where. I think that would make sense here. So do a dot where on a table, and we'll get pieces of it, right? So let's start with our, like we're trying to guess a word, and it's a words table that has every Wordle word. So our goal then is, all right, give me all the words where there's an E in them, right? Because E is the most popular one by far. We better be guessing a word with E in it for sure, right? So let's do that, and let's figure out what to do. I think it's this documentation page that has, oh no, they all have the predicates, never mind. Is containing, right? So where the words column, okay, words.where, it's called words with a capital W, where the words values are containing, and then in there I put a string that I want it to contain. It can just be a 1-character string, right? E. Because like that's what I need here. E, give me all the words with an E in them. Yeah? Does that make sense to us? Like why I would ask for that? Bam. So that's whittled it down. There were like almost 2,500. Now there's just a little over 1,000 left with E's in them. All right, so like these are better words to guess. And then all right, once you've got those, you can whittle it down further. All right, give me the ones with E's and A's, right? If you want E's and A's, you just take what you did. These are the ones with E's, and then just do another dot where. Does that make sense? It'll get a little long. It's like, all right, take that table, dot where, all the words now in that one, and that new whittled down one also have an A in them. So like that's the next most popular letter. Does that make sense? It's a little weird. There's a better way that I'll show you in a second. But all right, now there's only 352. These are getting better, right? These are more, and maybe you look through all these and see like, what's the best looking one to you? And then also an R. R is the next most popular one, so we do the same thing. It'll get a little long and disgusting, but that's okay. It's like, all right, get that new whittled down table. Do a dot where on that. R is important. There's only 120 or 129 now because the first 10 are shown. So these are better words to guess. Do we have any with also, the next one's an O, right? I do an O at the end of that. Let's see. I'm pretty sure there's not one after that with like a T as well, but we'll find out. Boop. Did I do all of them? Did I copy and paste right? So E-A-R and then an O. There's a few of them. Cool. And now this is the trick, right? You're not actually sure if these are the best words. Because none of these also have, a T in them, right? If they had a T in them, that'd be great. Then I know for sure that's the best word to guess. But all of these other ones, they don't have those. I have a door, right? What's the we got D's, S's, or P's. Where are those? P is way down there. S is over there. What was the other one?
D.
D?
Mhm.
Or that one is also way down there. So that's actually maybe not great. Because maybe it would be better like take the E, the A, and then maybe like do the L, T, and O or something. Like there's other ways that you could find good words. And so maybe these are not ideal, but at least you have options. Like you could have stopped sooner, like look through these 129 of them. Like that would give you some good guesses and then compared to the table. But I'm of course not done. But does what we have done so far make sense to us? That's kind of cool. Let's see, what do I want to do? Yeah, so that's one way of thinking about this. Just like, all right, I've got this graph with all these frequencies. I've got this distribution, right, of characters. And like I want to just like take the ones with the E's, the A's, the R's, O's, T's, as much as I can, and look through them manually. But I mean, we also have a computer in front of us, and we can have it do that for us in a way. So what I think I'd like to try to do next is, and last, is let's try to make a score for every word in Wordle. Like come up for every word, make a number out of it. And higher scores would be more like words using more popular characters, right? Because I want to pick the highest, like I want to make some sort of number that corresponds to how good of a first guess that Wordle word is. All right. And so one way to do it would be like, all right, I've got a string, like I don't know, like adore. I've got adore. And what can I do to that, right? I've got stir, I've got adore. I can make an array of all the characters in that word, right? Stir to array is what we called that. So I've got adore. And I can go through, like that's, that I can turn into array. I'll call it array. There it is. I can go through all of my counts for each of those letters, right? I can take the A's, count how many A's, take the A's, the D's, the O's, the R's, the E's, and kind of like add them up. Like, I don't know, let's say, let me just do it and then I'll show you what I mean by it. Letters and counts, dot where the letter was equal to that first character. How do I get the first character out of this array? I say, like it's called array dot item 0, right? That would give me just the A. So where the letter value is equal to that, so I can say r equal to that, or just like leave it there. And that will give me this column. And let's say that having an A in this string contributes a score of 979. Does that kind of make sense what I want to do? I kind of want to add up that. And that will give me with higher numbers would mean like, okay, yeah, that word was using more frequent characters. Does that make sense? And so then a higher score, if I add up all these counts for all the letters I see in this word, then I have maybe a means of comparing these words in a numerical way. So that's kind of neat. So if I want to get the 979 out of this deal, like that's how I got to here. I get the row out now. I can say dot row 0. And again, this is kind of like an array where you can like get item 0, 1, get the count out. So that would that's the first character, turn it into the 979. That's how many A's were in every Wordle word. And like that's like a score associated with having an A. All right. And so like if you had a word that was nothing but 5 E's, then maybe that'd be the highest scoring thing. But like that is a way to calculate a score based on these frequency counts for every word. That's just something I came up with. All right. That's not something that maybe there's a better way to do it. I think there is a better way to do it. We'll talk about that in a second. But like that's a way to come up with a number per word, where a higher number would mean that it was using letters that were more frequent in the Wordle words. So then you can maybe sort by that. Okay. So let's do that. So like start a score variable at 0, like add to it for each of the letters, because we know there's only 5 letters in all these. Like score equals what it was, plus this letter's score, like the amount of A's, like how many A's were in every Wordle word. That was item 0. And then just like keep doing that for all the other indices. I know for the D, for the O, for the R, oops, for the E, And what that's going to do is it's going to take each character and give back the frequency count in all the Wordle words, and that's going to be my score. So like the score then of the word adore is 4,258. I've just added up the frequencies of how many A's were in the Wordle words, how many D's were in the Wordle words, and that's kind of like giving you a way of comparing, right? With higher numbers, then that means your word was using more popular letters. Does that kind of make sense? That's one way to think about it. And then we can sort by that. So kind of I want to do this process for every word and see how good they were in that way. All right? Any questions about that before I do it? Because I think it's going to take another function, right? So I got this words table. I want to attach to each word its little score based on what we've done so far, and that can be an apply of that new function. Yes?
So what score basically is just that it's going to look at the word and basically say this is a high likely chance to use this word or the letter.
Yeah, what it's doing is like, all right, it's going to go through this, say it's a door that we're trying to score right now, come up with how good of a word is that to start with in Wordle. We'll take every character, the A, the D, the O, the R, the E, because we know how many times every A appears in every Wordle word. Let's use that as a score, because if it's higher, that means that it was better to use that letter. And so I'll use all those counts. How many A's were there? 979. How many D's were there in all the Wordle words? Let's do it in order. There were 393. So that's not contributing a great score, maybe. Maybe you want a letter without it, or a word without a D in it. But if you add it up, if you turned each character into a number like that, based on these frequencies, then a higher final sum would mean that you were using more popular characters. Does that make sense? That's the way I'm thinking about it. Is that clear? There's still problems. We're not done with this yet, of course, but that's kind of where I'm going. All right. So I think that's a good number, at least to start with. I think there's a way, and we'll talk about a way to like make an even better scoring system. But this will get us somewhere kind of cool, I think. So let's make a function that takes like here's us doing it for adore, like this process, plus this process. Let's do it for any word that we could ever be given. So instead of hard coding adore here, let's take this entire process and turn it into a function, including all these things. Where who knows what I didn't need that part. Who knows? It wasn't adore. It was like some word called word, let's say, that we were given. So let's make a function. Def, I don't know, get score back for a word called word. And then do all this, please, where we take all the characters in that word, can convert it to an array, build up a score, and return back that score eventually. All right? That's what I want. And so that will give me a way then of getting a score for everything. So like get score or adore. There it is. I can do it for every word now because I have this. And so this is a function that I can apply to my words table. Right? I can apply it to my words table, get all these scores back. It's a silly idea, but it's just a good example of things, I think. I say words.apply to, I want to apply the get score function that I just made to every element of the column called words. So I could spell out words as a string, or I could be like, column 0, please. Column 0. And then here, it's going to take a second. And then here's an array of all of those scores. Beautiful. That's what I have. So I guess I just want to make a new table called, let's call it words with a brand new column. That is that one, right? Call it score. And that's how you build it. Do that apply. And then I'll call this resulting table words with scores. Words with scores. Boop. Cool. And so for each word, I've come up with a numerical way of scoring that word based on the characters that are involved in it to see how popular, like, is it using popular characters of Wordle words? So a higher score means it's using more popular characters. Okay? That's what it's doing. And so you better believe we're going to want to sort this table now, right? Let's sort it descending. Let's sort it. First of all, any questions before I move on? Like, let's sort this table for sure, right? You ready?
If you scroll, scroll up a little bit.
To where?
Right there.
I have a.
Mm.
Yes.
Yeah.
I made the table letters, and then when I try to apply things, it says it doesn't have a type, so I can't apply functions.
Oh, well, show me real quick. Who's taking it down? Why turn this into? Yeah, at least I don't have ones on that. I'm very sorry.
It's okay. I'll figure it out.
Okay. Sorry. I typed the letter A to get a new box above, and then it might have done something else. Unfortunately. But yeah, let's try to sort this table. Are we ready for that now? Let's try it. Let's try to sort it. Let's see the best scores, and we're gonna see something that's not great, but good enough for us, something that we could improve on. So where's scores dot sort by the scores column for sure. Sort by score column descending equals true. Cool. So here are the words according to our score that have high scores. Does it necessarily mean that a high scoring word is the one you should guess for? Should we be guessing eerie as our first Wordle word? If you played the game, you'll know that
No,
there's something going on there. Why not?
there's too many E's.
Too many E's. But like that's how we calculate our scores, right? E was the highest scoring thing. So obviously it's going to prefer then words with a bunch of E's in them. But that's not good for us because that doesn't give us extra characters. And so we now have an issue with duplicate characters, don't we? I would like a word that's high scoring but also does not have any duplicates in it. Does that make sense? That's what I really want. So that might change the way we want to score things even. Going back to our letters and counts table, you might not want to count. If you have a word with two E's in it, just going back to this, you may want to not count that second E because that's going to change how everything scores. But let's say we're fine with those scores. Let's just try to extract only the words without duplicates now. So let's try to figure out how to do that. All right. Here is the secret. Using what we know about tables, I can make a table with a bunch of letters for a word I care about, like eerie, for example. I can make a table with a column called letter or something. Stir to array, right? That function is getting a lot of use. That's a great function for us. Eerie. So I can make a table with every character of a word. Does anybody have any ideas if I have this, what I could do to see if there were duplicates in this word? Any duplicate letters at all? It ended up being a table operation because now I've turned it into a table. But can anyone think of a table operation that could tell me, maybe indirectly, whether or not there are duplicate letters in this word? Yeah.
You count non-zero greater than 1,
But what would you be counting?
or like roll equal to the first item.
Ah, yeah, you could maybe iterate through. That's good. Other idea? You could do dot group. I think that would be even faster. So let's look at both ways. So you could be like, you could somehow iterate through whatever the word was, or you like get row 0 dot row 0 item 0. That would give you the E, and then you can do a dot where on that E, where all the values in the letter column 0 are equal to that E, and then you can get how many like num rows, right? like, oh, it's bigger than 1. That would totally work. But I think a group would be great here. Going back to this. If I grouped by letter, look at what would happen. I get some counts there, right? That's great. And go looking like, oh, are there any counts bigger than 1? That would do it. An even faster way to do it, I think, would be, do you see how it made the table smaller? Just like this resulting grouped table, how many rows are in there? Because if it's not 5, I don't care about this word anymore. Does that make sense? That's kind of neat. That's fun to think about. So there's a bunch of different ways to do it. I think it's probably the fastest way is this one, using what we know at least. So that could be a function now. You give me, well, it has duplicates. You give me a word. I will tell you if there's any duplicates in it by saying, there's all the rows in it. Let's see here. Let's call this, I don't know. That's the number of unique letters in that word, right? Unique letters. How many rows are in this resulting table where it's not eerie anymore. It's whatever the word was that we were given. That's the number of unique letters. We wanted it to be 5, right? So if it was 5, we're happy. If unique letters is equal, double equals, right, to 5, then I kind of want to do a number here. Just, I could be true or falsing this if I wanted to. But what I would like to do eventually is attach a has duplicates column here and have it be like 1 if there's duplicates. Oh gosh, how do I want to do this? Dun, dun, dun. Excuse me. I'm thinking of it backwards. I want to I want to filter it out. Like, let's say a 1 if there's duplicates, a 0 if there's not duplicates, something like that. Or like even a yes or a no would work. Gosh, what's the best way to do it? We can do it with 1s or 0s or strings. Let's do it with numbers. It's weird that way. Let's just say 0 if there's no duplicates, like a false, else return 1, right? Because if it's not true that if there's 5 unique letters, return 0, that means there's 0 duplicates, I guess. It's false, no duplicates at all, no. Otherwise, return 1, kind of like true, yes. Yes, there are some duplicates. Does that make sense? Like that would work. Though I do kind of like no and yes, I don't know. Like to say, no, there's no duplicates. Yes, there are duplicates. That would also work. Or you could say true or false. Either way, all the ways are fine. I think that's useful. So here, there's a function. Words with, here, has duplicates. Eerie? Yes. Has duplicates. What was it? Adore was the other one? No. So, all right, let's try this. So words, let's make a table with that attached to it for every word, in addition to its scores. So start with words with scores. I like to add a column with column. And what I want to do to that column is apply, right? Let's do that first. Words with scores. What I want to do is apply this function called has duplicates to the words column. Okay, to the words column. Boop. Just like that. So a bunch of no's, some yeses, right? Some of them have duplicates, some of them don't. And I just want to extract the ones that have no duplicates. So like that's going to be my new table. So we'll call the new column has duplicates. And then here are all the values I want to put there. So make this array again for me, right there. And I'll call this new table words with scores and duplicates, let's say. Something like that. Cool. And so you got a lot of these that have or don't have duplicates. And now I think we're in a great place, right? Because again, we could say this, like sort by the score reversed. Dot sort by the score descending equals true. But now we have duplicates information attached. So, right, we could extract that with a dot where. Does that make sense where I'm going? Any questions about how we got here before I go there? Yes.
I could just go over some of them.
You gotta start taking pictures, man.
I know. It's like you get typing and then I can type it.
You good? Yeah. So yeah, that's my information so far, and then I hate all of these words right now, right? I want to get rid of them. I want to filter dot where has duplicates, where all the values in the has duplicates column are zero, or sorry, not zeros anymore, where they're no's, right? Where they're equal, the values are equal to no. Does that make sense what that's going to do? It's already sorted. Just filter out the ones with no's, and there are some better words. Maybe we could have calculated the scores also without duplicates. That's also something that we could do there, and it will change the order. It will change the order, because then E would have a lower score total, for example, because there's a lot of words with multiple E's in them. If you didn't count the second E, like this would change a little bit. So there's ways to go here, things that you could change, but I think these are some good values. I like to use irate when I play Wordle, and this is justifying that kind of. But apparently, like later is a good one. Alter, alert, arose, still there, and like adore wasn't there at all. Crazy. And so I think these are some good Wordle words. Are they the best? According to our definition of best, according to our scoring system. But there's better ways to score potentially, where you also consider duplicates when you're calculating the score for A's and B's and C's, where you're calculating those frequencies. But I think that is a great, some good numbers at least. Are there any questions about what we got? Because it took a long way to get here. We did a lot of different things, a lot of different functions that we applied, used. Very useful, I think. Some good examples of everything. I guess the last thing that we could do is like, all right, given all these words without duplicates and all their scores, I guess the ordering doesn't matter anymore. But like, we draw a histogram. That's one last thing that we could do. Like, what's of an average Wordle word? How bad of a guess is it? We can do like a histogram on the score column. I did not have to sort first because histograms don't care about that. But you can give different bins if you want. But with the default bins, let's say, it looks like it's very uncommon for us to have large scores up here in the 4,500 range, which is good to know. Like, if you guess some random 5-letter word, it's probably going to be not great in terms of our scoring system. A little over 3,000, 3,250, which means that it's not using the most popular words most often. There's some words with some really low scores as well. Maybe we can look at those if we want to. We can see that they're way down there, but there's not a lot of them. We could sort in the opposite direction to see those. Like, these are the words you should absolutely never guess first, even if there weren't any duplicates. So let's see. No, we do the ones without duplicates. Sorry. I would like to do this one in this way. Without the descending, but with the, okay, something like that. So like jumpy, that is the worst first Wordle guess, even though all the letters are different. If you got rid of the has duplicates, like what's the absolute worst Wordle guess? Fuzzy. Now we know to never get, if you want a challenge, you will guess fuzzy first. Okay. Yeah, I think that's the moral of that story, and we explored some data together and learned more about it and reviewed a lot of stuff. I think that was all that I had planned. Are there any questions about any of this? So yeah, just trying to touch on most of this, right? Most of everything on this page, because you'll have access to it, and this one as well, whichever one you'd prefer, as you take the test. So there's that. Of course, there's more than just programming stuff that I might ask you about. I might ask you to calculate stuff based on that. I can't go over everything that could possibly be here. So definitely look at the slides, look at our past examples, your assignments, all the chapters, go back through them. Because like there are some chapters that weren't even, like chapter 2, for example, just about experiment design and stuff. It had nothing to do with coding, right? I could ask you about that for sure. I could ask you about probabilities. We didn't talk about that today. There's other things, but I believe that you could study those things. All right, this is like getting all the technical stuff so that you're ready to use Jupyter on the test. I think that was my goal for the day. Yeah, but I think that is everything that I wanted to officially say. Are there any questions about anything that you'd like in the recording? Because, of course, you'll get to watch this again and you'll get all the code. Yeah, if we're good, I want to give the rest of the time to you then. So study, do whatever you need to do, ask questions.